everybody. In this video I want to talk about even and odd functions. So remember the talk that I did about finding symmetry and testing whether or not an equation is symmetric. This is going to be similar to that. So testing to see whether an even or whether a function is even and odd is a great way to test for symmetry in the function also. So the criteria for a function to be even is that f of negative x is going to be the same as f of x. So if you recall, this is basically what the definition is for symmetry in the y-axis. So this is y symmetric. Because you're going to get the same y value whenever you plug in the negative version of the same x value. So like if xy is on the graph, then negative xy is also on the graph, which is the definition for y symmetry. And for an odd function, I don't need to write that out. So for an odd function, we've got f of negative x is going to give you the negative version, the negative value of f of x. So basically what this says is that if xy is on the graph, then negative x and negative y is also on the graph. And if you recall, this is the definition for origin symmetry. So it's pretty cool. This is a pretty basic litmus test to see whether or not a function is symmetric. So let me go through a few examples in showing you guys this. So let's say that I had f of x is equal to x to the fifth plus 4x minus 7. So first of all, I want to test whether or not this function is even. And to do that, all I have to do is plug in negative x in for f of x and see if I get the same result. So I'm going to do negative x to the fifth plus 4 times negative x minus 7. And what's this going to give me? Well, negative x to the fifth is negative x to the fifth, because if you raise a negative number to an odd power, you'll get a negative in return. And then times or plus 4 times minus x gives me a minus 4x minus 7. Now, is this original to our original function? Or is this equal to our original function, which is x to the fifth plus 4x minus 7? Well, no, it's not, because we have these two negatives out in front, which differ from the original function. So this is not an even function, which means that it's not symmetrical in the y. So let's test and see if this is an odd function. So we already know what happens whenever we plug in negative x from when we tested for the even function, but let's see what negative f of x is. So if I had negative f of x, what's this going to be? So it's basically the same thing, I just switch all the signs. So negative x to the fifth minus 4x plus 7. So we already know what happens when we plug in negative x into the function. We get this guy right here. So if I set it equal to negative f of x, are they going to be the same? And the answer to that is also no, because these signs differ. We're closer than the even function, but not quite there. So this is not an even or an odd function, so this is neither. Neither even nor odd. Boring. Alright, in this next example, I've got f of x is equal to x to the fourth minus 20x squared. So if I want to test and see if this thing is even, what I'm going to do is I'm going to plug in negative x in for x into the original function and see if I get the same thing back. So f of negative x is going to be equal to negative x to the fourth power minus 20 times negative x squared. So check it out. I have negative x raised to the fourth power. When you raise a negative number to an even power, you end up with a positive. So this is going to give me an x to the fourth in return. I have a minus 20, and again, minus x squared just gives me positive x. So this is what I get when I plug in f of negative x. And let's see if it's equal to the original function. looks like we're good to go because all the signs check out and everything is maintained. So this is an even function, which means it's going to have symmetry about the y-axis. But let's just check and see the odd version. So if I try negative f of x, what's going to happen? Well, negative f of x is going to be negative times f of x. And when I distribute this negative out, I get negative x to the fourth plus 20x squared. And let's see if this is equal to f of x. So x to the fourth minus 20x squared. We know that this is not the same because the signs differ on all the terms. So this is not an odd function, it's only an even function. Alright, let's say that I had f of x is equal to 2x times the square root of x squared plus 3. So first I'm going to check and see whether the function is even. And I'm going to do this by plugging in negative x for x in the function and seeing what I get. So f of negative x is going to be equal to 2 times negative x times the square root of negative x squared plus 3. And when I work it out, I end up with a negative 2x out in front. And negative x squared is just x squared. And I have a plus 3 inside the radical again. Now, is this equal to f of x? Now, unfortunately, you can see that it's not equal to f of x because we have a negative sign out in front, and the other side does not have that negative sign out in front. So this tells me that this is not an even function. Now for the odd case, I know that f of negative x is equal to negative 2x times the square root of x squared plus 3. So if I were to find negative f of x, this would just be the negative version of f of x. And if I multiply the term by the negative, I end up with negative 2x times x squared plus 3. And interestingly enough, this is equal to negative, or f of negative x. And what that tells us is that the function is odd because the two sides end up equaling each other. So this function is an odd function, meaning it's symmetric about the origin. Okay, in this last example, I've got f of x is equal to the fifth root of 6x squared. So the first thing that I'm going to test is to see whether or not this function is even. And I'm going to do that by plugging in negative x for x and seeing what I end up with. So f of negative x is equal to the fifth root 6 times negative x squared. Well, negative x squared is just equal to x squared, so this is going to give me the fifth root of 6x squared, which you can see is equal to the original function. And what that tells me is that f of x is even. But to check the odd case, I'll have negative f of x, which is equal to the negative version of f of x. So I have a negative fifth root of 6x squared, which we know is not equal to negative f of x, which is, or not equal to f of negative x, which is the fifth root of 6x squared, because the signs differ. So this tells me that f of x is not an odd function, and it's only an even function. So I hope this video was helpful about determining which functions are even or odd. Even functions have f of negative x equal to the original function, and odd functions have f of negative x equal the negative version of the original function. So a little bit of practice may be required to not mix up those two definitions, but that is the essence of it. So I hope this video was helpful, and stay tuned for the next one. Take care, everybody.